of YouTube videos, I watched a lot of YouTube videos, read a lot of books before I could later grab it. But trust me, once you know C, forget anything in programming is like biscuits. Like I always tell people, C is the programming language that helps programmer to see. So if you don't know C, probably I wonder how you can see. So let's get started. Today's I just titled it, demystifying C and arrays. How things actually work under the hood. Behind every system, we have C. And also, like I will just be sharing some concepts and explaining some things. Please, if you have any questions, you can just signify so that I can answer some of the questions. And as you move on with your learning for week 1 and week 2, things become more easier for you. So demystifying C and arrays, how under the hood, how things actually work. So some of you have watched the video, some have just watched the video, but in the video, you have seen how the man explained what a computer actually understands. So very briefly, I would like to explain. You see, the computer we are using, the laptop we are using, sometimes most of you, if you type your name, you type anything, any words, any number, the computer displays, you use a calculator on your laptop or on your phone, it brings answer and everything. You prompt ChatGPT, ChatGPT give you response back. All of those things are actually if you actually understand how it works, you know that technology has actually come a lot of distance, and it has helped humanity in a lot of ways. Computer does not actually understand what I'm displaying right now, that title demystifying C and arrays. Computer does not understand this alphabet. It doesn't understand all these letters or anything we are saying. What computer understands is zeros and one. Then why is it so? Because how computer is built is that computers are built using transistor. I don't know if many of you are not in electrical, but I will try to break it down. Transistors are just like an electronic switch that either turn on or off. And most of us, we are familiar with the concept of binary. Binary is just zeros and one. That is, if a transistor is at a state of 0, that is off. If it is at a state of on, that is 1. So that is on and off. A transistor, like I said, is like a switch, is like a bulb. You can view a transistor as your normal bulb you have at your home. So if you turn on your bulb, then the transistor is in a state of 1. If you turn it off, it's in a state of 0. So that zeros and 1, that is what makes up the computer we are using today. Then how then does a computer now understand or translate zeros and 1 to whatever alphabet, to whatever letters we are using in this modern day? When most of us in secondary school or in 100 level, 200 level, some of us did binary. I'm sure all of us, some of us are in engineering, some of us are in computer science. So we did the concept of binary. So there is a way we can convert binary, which is zeros and 1, to decimal, which is that goes beyond zeros and 1. We have 2, 3, 10, 11, 50. Then we have what we call hexadecimal also. So from the concept of that binary, there's a way you can convert from binary to decimal, and there's also a way you can convert from decimal to hexadecimal. From hexadecimal back to decimal, then decimal back to binary. So you can actually convert all of those concepts back and forth. And if you know hexadecimal is very close to letters because it has alphabet and letter. You can see something like 16A, 15B, something like that is hexadecimal. And decimal is like 10, 1.0, stuff like that. Then we have also binary, which is zeros and 1. That is basically how machine works, and that is how computer understand whatever we are doing today. So that being said, now what it does, that's how computer works, and what it does. You see, all of these things is, like I said, is like translation from binary to decimal, from decimal to. So the modern day, the advent of programming language starts from zeros and one. People program in zeros and one. The likes of when you go to back to using COBOL, using Fortran to code. I don't know, some of you did computer science in secondary school, so they will have taught you all of those things. Then fast forward to, there's something we call assembly language. For those of you that have watched the first video, you will have understand like different type of programming. Like we have the assembly language, we have the low level language, we have the high level language. So we have the assembly language. This one is like basically in hexadecimal, where you use 16-bit, decimal and alphabet to code. But now moving from the assembly language to low level language, which a typical example of low level languages, we can say C is an example of a very low level language. It's in between low level and high level language. So that is why, okay, I think that will bring me to the next slide, if I'm not mistaken. Oh, sorry. I think I'll still be here. So as I was saying, in low level language, humans, we are tired of writing zeros and ones. We are tired of writing hexadecimal, programming in hexadecimal, which is assembly language. Then let's write program in how we can actually understand. So then, if you look at C, if you look at the likes of Python programming language, for some of you that are familiar with Python, or you have ever seen a Python code before, or any JavaScript code, you can literally read them in English language, because you can read them in English language, and sometimes you can understand them. Not all, like C, that some of you find hard to understand. But if you still look at some things, you look like, for example, if you look at the printf word, print hello word, how they print hello word, you can literally see that they are trying to print hello word to the screen. So you can understand all these languages since we have moved away from hexadecimal and binary. Now, there is something, because our machine does not understand alphabets, like I said, it only understands zeros and one. Then there must be something. It's like, let's say I speak English and someone else speaks Yoruba, and I don't speak Yoruba. The other person doesn't speak English. So I only understand English, and then you only understand. Then we have to find someone that understands the two language and can interpret between the two of us. For example, now let's say two presidents, let's say the president of Russia and president of China, they are meeting now. A Chinese president doesn't understand Russian, and a Russian president doesn't understand Chinese. So there has to be something between them that will be interpreting that language between the two of them. So that person has to understand what we call, must understand Chinese, at the same time understand Russian. So when a Russian president speaks, he interprets it to the Chinese president, and when the Chinese president also speaks, it's what it interprets back to the Russian president. That is basically what we are trying to achieve in this C programming language, or in every other programming language. But we have levels to all of these things. Like we said, C is a low level language, but Python, as an example, is a high level language. So for a low level language, they don't use interpreter, they use something we call compiler. So they use something we call compiler. It is that compiler that will now translate whatever in code or program we write in English, that will not translate it to our zeros and one that machine actually understand. Then machine will now run our code and give us back whatever output or response that has been programmed into the code. So if anybody have questions, let me just give some 1 minute for questions. If anybody have questions, can you just raise up your hand? Please, if you have questions. Okay, in the absence of none. So, next slide. Foundations. We have to understand the machines, types, memory logic, debugging. So basically, what C is trying to teach us is the understanding of machines, like how machine actually works, how they are built and everything. So then building, ship working things, real code, real tools, real repository, and also we use it to solve problems. So I'm just trying to move fast so that I don't waste much of our time. So the next thing is that you came here for AI, you are starting with C. Some of you might be wondering because some of you might have actually like make your research and online and you have realized that most people or Python is actually popularly used for AI. Then you'll be like, why are we like learning C? Why are we starting with C instead of starting with Python that is simple and all of that? So this is just like a basic rundown of why C is very important for every programmer and most importantly for you that are trying to learn AI or solve problem with AI. So AI runs on memory. You cannot see.
What is it from my end or can we hear him?
No, sir, we cannot hear him, sir. I can't hear him. Oh.
Okay. Let's just hold on for a minute.
Tensors
Okay,
in
you're
programming in
back.
AI rather. We have something called tensors. You can't see my
We couldn't hear you before, but we can hear you now.
oh sorry, I didn't know that. Can you hear me now?
Yes, we can.
Okay. So, like I was saying, like some of you might be wondering, we came here for AI, then why are we learning C? Why are we starting with C? So I said AI runs on memory that we can't see. Like, and if you look at AI, like I explained earlier, that machine doesn't understand words, letters, or alphabet that we humans speak, doesn't understand human language. We only understand numbers. So there is something we call tensors in AI. Tensors are just like a numerical representation of words, letters, and alphabets. So all those letters and alphabet, they run on memory. And if you don't manage your memory very well, trust me, you can there's no way you can train AI model, there's no way you can use AI effectively. Just know that. And the second one, I say out of memory is a C problem. You know, some of you might have, like, for example, when your memory is full on your laptop or your phone memory is full, there's no, if you want to try to, collect some files or any data into your phone or your laptop, you will get like memory is full. So C programming language is actually like the language we use to manage memory in programming. And also forward deploy means cushion. So on a client system, you debug code, you do not write code. In a language, you do not choose. Fundamental travel, framework trees do not. And Python also taught you to trust. So I'm just trying to save time so that we can do um a lot of things today and we can cover everything. So these are the things we cover: source code versus machine code, what compiling actually means and what it does. Then your first C program. Then we are going to do a memory as a grid of mailbox. We are going to go into data types and why they exist. We are going to go into arrays and counting from zero. We are going to do conditional statements and loops. Then the limit of real hardware. Then we are going to use ASC, II, then characters and string, then command line input and debugging. So to the next slide, source code. What do we mean by source code? Most of you might have been hearing the term source code, source code, source code. What does source code actually mean? And what does machine code actually mean? Source code actually is a human readable code, whether in C or in Python or in JavaScript. Whatever code you write to solve a problem, or whatever code you write to explain a concept is actually a source code. But on the other hand, we have something called machine code. Machine code is basically the zeros and one that we say machine understand. Machine does not understand our source code, it only understand machine code. So, and if you look at the analogy I make here, between our source code and our machine code, there is something called the compiler. What the compiler does as I explained earlier, it does what it interprets our source code into a machine code, and that is where the C-lang framework comes into play. So there is the framework they use, I mean the compiler they use to in C programming language is called C-lang. Some other like compiling programming language use another framework, but in C we use C-lang. Basically for C-lang, it means C language, or we use make for it. So next slide. So for those of you that have watched the first video, you will have seen this code. This is the first code like we come across in the C tutorial video if you have watched it. So this is where the new work started, and this is where some of you are confused. If you look at the first line here, it says hashtag. We have hashtag. We have include, hashtag include. Then there is in this bracket, this less than and greater than. You have something in between called stdio.h. You see this line. This line, wherever you see anything called .h in C programming language, they are called header files. Headers files. HEADER, header. They are called header files. And what are header files for? What are they and what they do? Why do we need to include them? Because trust me, if you don't include this in your code will not, it's not going to work. It's never going to work. And I will explain why. It's not going to work. Okay, thank you. Sorry, my network is, I think it's kind of poor, so that's what I'm trying to. Okay. So thank you. This STDIO stands for standard input and output. STD. Look at the spelling very well, not studio.hu, it is STDIO. And that STD stands for standard. I stand for input. 0 stands for output. .h. So this header file, this stdio.h is an header file using in C. And we have a lot of header files. If you have watched the video, you will see something where the CS50 class, you will see they have their own header file called cs50.h. Some of you that have watched the video, you see something called cs50.h. So it is a header file built by CS50 class, and they have a lot of functionality, a lot of functions in that header file. That file is just like a library in C programming language. Every programming language has a library. And what are libraries? Libraries are just like, they make our life easier as a programmer. For example, now, let me explain this stdio.h is a standard input and output library in C that you have to include in your program for your program to be able to run successfully. And it does a couple of things. For example, if you look at this code now, we have something called printf hello world. So this printf hello world is actually like printing something into the screen. But the operation here is an output operation. So without this header file, it is not going to print anything. So it is inside this header file library that we have this functionality or this method called printf. So for some of you that have watched this, we have something called getString in that video. The first method they use there is getString. So that getString function is like a method inside CS50 library. It's a library they created themselves. It's not a standard library for C, but that library is what CS50 created themselves, and they include a lot of functionality in that library that you can use. So if you watch the video again, there's a way you can, if you go back to the video, as some of you are going back into it, all of you actually. So there's a way you will be able to view that library and you will see all of the functionality inside that library. So the same thing as this standard IU.H library too. It has a lot of functionality. One of it is this printf. Another one, we have another one to take inputs. We have scanf. That one, you use that one to take inputs. You use printf to give out outputs. So like I say, this standard input and output, without it, all of this functionality will not work. It will not work. It will not work. So what are libraries? Like as I was explaining, libraries are just like a form of code that other people are written to make your work very easy. For example, now, let's say Okubanjo, for instance, now, they gave you an assignment on this group, and Okubanjo has done his own assignment. Adoku Emmanuel, let's say Adoku Emmanuel has not done his own. But Adoku does not understand how to actually do it because of time constraints. Time is going and you want to submit the assignment very fast. You go and look for, go and meet Okubanjo. Okubanjo, what are the formula what are the formula you use to solve your assignment? What method did you use? Like some of you, like if you are trying to solve, let's say for instance, quadratic equation, you have different method of solving quadratic equation. So you go and meet Adoku will go and meet Okubanjo on that. Okay, I'm finding this quadratic equation very hard. I was trying to use the almighty formula, but it couldn't work. What did you use? So what Okubanjo will do, instead of Okubanjo as is raising up his hand.
Okay, so I wanted to ask if we could make the slide full screen so that I'll be able to see it clearly.
Okay, you can see it clearly now. Sorry.
Is this Google Slide environment or PowerPoint? But if you could make it full screen so that we'll just be seeing what is there.
Okay.
I think you can put it to slide. If you see that place that says from current slide, you don't need to reshare or anything.
That's right.
Exactly.
Is it okay like this?
Yes, very well. Thank you.
Yeah, thank you. Okay, as I say, back to my point. So instead of Adoku Emmanuel trying to solve everything from scratch on his own, trying to write the formula, trying to define the logic, trying to define every logic and every function to solve the quadratic equation, you can just go and meet Okubanjo that, how did you solve your this thing? Give me like the manual, or give me whatever manual you use to solve your problem. Then Okubanjo can just say, okay, I use the manual that was given to us in the class, page something. Go and follow that pattern. Then you need to solve it. That's what library are. So I said earlier that without this standard stdio.h, without this header file library, you can never print something, your code can never work. That's true, but if you know C to some extent, you can actually do it without this standard library. But this header file library actually makes your life very, very easy. It makes your work very, very easy. So you will just go into the standard input and output library, go and look at all the functionality that is inside of it, go and look at what they solve, and instead of writing everything from scratch, just write the function name they use and how they use it. They come and use it in your code. It is as that simple. It is simple as that. And by the time you move to Python, you move to JavaScript, you have a lot of similar concepts too. We have libraries in Python, we have libraries in JavaScript that instead of writing things from scratch, you just have to import the library, then use the library. So now let me now explain it one by one. If you look at include actually means that since this standard stdio.h is a standard library in C, so you just need to call it. You don't need to go and download the library. But for cs50.h library now, for some of you, if they are going to use VS Code to follow along the course to write the code and everything, you might not, like if you want the cs50 code, it might not like any other get string function. and you import the CS50.header.h header file library, it might not work because you still need, first of all, you need to go and download it inside VS Code so that you can use it. The reason is because CS50.h header file library is not a standard library in C. It is a written library written by CS50 by Harvard to foster like the learning of all of these things. But we have a lot of standard library in C. So for standard libraries, you don't need to download it, you don't need to, you just need to like import it. So instead of saying import and include word now, just like a way of importing the library that, okay, I need this library in my code. Just come, let me use it. That's what it does. Then include means you are importing the library, then the name of the library you are trying to import, and that this is the function. This is how you write the library, the name of the library. You write the name of the library, and then at the left side and the right side you put your less than and greater than. That's the functionality. Is that clear? Does anybody have questions? These are just like the basic things you need to understand it, and it will it will make your life easy. So if you have any questions, raise your hand. I will attend to you. Oh, we are already in 6 o'clock. Let me just try to fasten things. So the next thing I would like to explain is curly braces. You know, we have brackets and we also have curly braces in C. We have brackets, we have curly braces. For some of you that are familiar with Python, you don't need all these curly braces in some cases. For example, if you look at
sorry, please. I was raising my hand. It seems you didn't see my hand. So I wanted to just quickly do a quick check to be sure that, guys, if we are here, if we are really here, can we just give a thumbs up? If you are not here, give a love emoji. Let's if you are not here. If you are not sure, give a laughing emoji. Okay, I can only see thumbs up. Okay, I can see a love emoji. Okay. No one is in the middle. If you're in the middle, just give me a laughing emoji. Let's be sure.
I think Christopher gives a laughing emoji.
If you're, you say?
I think Christopher gives a laughing emoji the other time.
Oh, I didn't see that. Okay, I can see from Christopher. I can see from. Okay, so yeah, so I think most people are catching up. So yeah, I think we're good. I just wanted to read the room.
Okay. So please, Christopher, please reserve your questions. I will attend to them. Just make sure you note them down so that you don't forget. So moving on, you will see curly braces, you will see semicolon, you will see, bracket and all of that. You'll be wondering, why do we need all of these things? Are they necessary in all of that? So one thing I would like to point out here is that if you look at, I don't know if I don't know like if many of you understand Python, but then I will just like use the two, because by the time you move to Python, you realize that there are a lot of differences between C and Python. A lot of differences. There are a lot of things you don't need in Python before you print your hello world and get it on your screen. So as I was saying, curly braces is used after you declare a function. For example, now if you look at this, after our included stdio.h, we have something called int main. Inside that main, we have a word called void. Then after that, inside after main, we have a bracket void. Then after void, we have curly braces up and down, the opening one and the closing one. Then we have inside of that curly braces, we have our printf, where we have our in bracket this thing, we have hello world and all. So this int main, if you look at main is a function in C, and this is how you declare a function in C. Int main. So once you see a word, like I'm sure many of you know that this int is just like a data type. We're still going to get into that. So just know that, okay, whatever code you are running in C, it starts from this function called main. If your code is outside of this main, like whatever code you are writing, if it's outside of this main, it won't work. It will not show outside. Although you can declare another function outside of main, but then whatever function you declare outside of main, or whatever variable you declare outside of main, or whatever anything it is you declare outside of main, it has to be called inside main, inside this function called main, which is between these curly braces, between the opening and ending of the curly braces, before that code can actually like work. So a fully functioning running C code starts from this int main function. So you define a function by stating the type of data type it is, then the name of that function. This one, you just name it main as the major main this thing. Then void stands for null. It is a void from the word void and an empty this thing. So in C, one thing we need to understand is in C, curly braces helps to group your logic into one block. It helps to group your logic into one block. What do I mean by it helps to group your logic into one block? I will cite an example. Let's say, for instance, you are trying to develop a calculator, for instance. For example, you're trying to develop a calculator. And like I said, this main function, this main, like the way it is defined like this in brackets and also in curly braces, it is a function like this. So let's take, for instance, you are trying to develop a calculator, and inside your calculator, calculator have a lot of functionalities. So from the word functionality, that means you have to like define a lot of function for your calculator. For instance, it will have a functionality called multiplication functionality. It will have an addition functionality. It will have division functionality, and it also have subtraction functionality. So you can define a function called multiplication function. So that one will just be like, let's say, int multiplication into brackets, whatever it has to return. Maybe that would be, what is multiplication now? Let's just say int multiplication into brackets. You can leave it empty, or you can pass an argument into it. Number 1 and number 2. You want to multiply two numbers together. Int main into brackets, number 1, comma, then number 2. Then you now open these curly braces. You now define your number 1. Number 1 is equals to scanf enter number 1. At the printf enter number 1. Then you now store that number 1 into a variable called number 1. Then you have another functionality called addition. You have another functionality called division. You have another functionality called subtraction. So basically what I mean is that curly braces, it helps you to group your logic together. Instead of writing all of your multiplication, division, subtraction, addition into one logic, you can group it so that your code can be readable and it can be neat. You group them using curly braces. You can group them together using curly braces. And also, another one is semicolon. A semicolon is the period at the end of every sentence. Trust me, every sentence in C must end with semicolon. I repeat again, every sentence in C must end with semicolon. If your sentence does not end with semicolon, your code will definitely throw an error. It will definitely throw an error. Then also, another thing you will see here is I've explained what printf does. I've explained what main does and all. So another thing you will notice here is the \n. The \n is just like an escape secret. It helps you to move to a new line. Is a method we use for new line. Maybe you are writing something in one line of code and that line is too long. You want to move to the next line, then you can use \n. So it matters for you. Like the simple note I left here is C never gets what you meant. Miss one semicolon and nothing else at all. Which once you get used to it is a gift. The box that ends career are the ones a forgiving language led through silent mode. So trust me, you really need to know all of this. And in the advent of AI, like I was telling Emmanuel yesterday, that most of you, even if they give you task, you are still going to use AI to guide the code. But during this AI time, AI era, AI does hallucinate a lot. Sometimes it will write the code for you. AI can miss the semicolon for you. But it is you as a programmer that you know that you are good and you are good. Then you will notice that, oh, what this error is saying that is semicolon. Then you go to that line, add semicolon, then your problem is solved. So like I think who was speaking the other, I think Ogubanje was speaking the other than that. Whatever this thing you need in this line, everything has already been solved. You just need to go and copy someone's code or go and do everything has been solved. You just need the logic. But sometimes all this logic is what we are teaching them. Sometimes the problem is just semicolon. Sometimes the problem is just curly braces. So moving to the next slide. In programming, like programming in general, they follow a specific pattern. Like I normally say is I can learn, like for now, I can learn up to like 10 languages within a week, because I have found it easy to learn one languages, and I know that most of them follow the same pattern. And but once you know that pattern, it is easy for you to follow you through with another programming language, in another programming language. So, like I said earlier, they follow the same pattern. There is something we call data types in programming, and you can find this in all programming language. All data type. So we have a data type called int, and of course it stands for integer. Just like integer, like most of you are familiar with this. It's just a whole number, like 1, 2, 3, 20. And we have another data types called character. That one is just like your alphabet. Or it can be a word, like your name. Your name is a character. We have a single character. We have character. We have another one called float. Floats are just like decimal number. 19.99, 1.0, 3.14. So it's another data type in C. And then we have another one called Boolean. That one, Boolean, is just like zeros and one, true or false. So, and as you move on into this C memory, array, data structure, and all of that, you know that all of these are like very essential. Because like I was saying earlier, memory is very precious when it comes to C programming language. Even in programming in general, memory is very precious. And I would like to cite one example. I don't know, some of you, if you are curious about, I forgot the year now. Like in the 1990s, they sent what's it called? Oh, what's the name of all this aerospace what Elon Musk is building? Okay, all this space. How do you say?
Satellite.
No, all this spaceship. They built
rockets.
Rockets. All of these rockets, they built it in 1990s. And if you look at 1990s, we only have like memories in 1990s. You can have a memory that is full of a room, and the size is just like, let's say 2 MB. The size is just like 3 MB. And if you look at these days, we even have a memory card that is very tiny, that is up to like 120 something gig, 220. Even our phone, we have some phone that have up to like 500 gig. So if you look at it, like what changed? So everything just like memory management and memory allocation. And C is like a typical example of language that helps us to manage our memory very well. Else, most of your devices are just going to be run out of memory in no time. That's why your operating system, most of them are written in C. Basically, all of them. Talk of Windows, talk of Linux, talk of macOS. Most of them are written in C because of what memory management and all of that. So memory is a very precious resources when it comes to this thing. Let's like, so we have mentioned variables in programming language, we have mentioned data types. And another thing is in programming that you will come across as you move on to the course is conditional statements, conditions. And this one is very, very key. Very, very key. Conditional statements. What are conditional statements? From the word condition, by the time you started writing your code, we start stating some condition. When you want some code to run and when you want some functions to run. Like I said earlier, you will be defining a lot of functions in your code. For example, the case of calculator, we are making you as an example. Let's say you have defined a function for multiplication, another function for subtraction, another function for addition, another function for subtraction. So when do you want your multiplication to run? When do you want your subtraction to run? And when do you want your division to run? Let's take a typical workflow of how a calculator works. A calculator now, you first take an input from the user. Let's say a user inputs a first number as 2. Then you ask the user for second number. Let's say it enters 3. Then you can ask them what operation. In your calculator, they will type either times or minus or plus. So let's say they input plus as an instance. So inside your code, you will have written a condition that if users mathematical operation is equals to times, then perform multiplication. But if users mathematical operation is minus, then perform what? Subtraction. So that's basically conditions for you. If we look at this typical example I highlighted here, is we define a variable called score. So have I explained variable? I don't know if I have omitted that or something. So basically, let me quickly go back to that. Okay, I have not. Variable. I think I forgot to include that one into this thing. So variable is like a container in programming that you store your information or data or whatever it is. For instance, I declare a variable here called score. But the type of data type we want to store inside this variable is called integer. We don't want to store any float number or anything. So that means if user input, let's say 85.1 or 85.0, then the operation is going to reject it immediately because the data type this program expects is what? Integer, not decimal, float, or any other thing. Even if you try to enter number, let's say you want to spell 85 in words, it's going to reject it immediately. So that is variable for variable are like a container that you store your data or you store any information. You can declare a variable called my bag, my school bag. You can declare a variable called my locker or my wardrobe. So basically, the idea of variable is that you can store something in that variable, and whatever you name that variable is what you are going to be using in your code. You don't need to be looking for the content again. So let's take for instance, you name a variable called my bag, and inside your bag, you will have a lot of things. Let's say you have your book, you have your pen, you have your pencil, you have your eraser in your bag. And if you are looking for your pencil or your eraser or your school materials, you don't need to look for them like individually. What you just need to look for is your bag. Once you have your bag, you have your pencil, you have your eraser, you have your book, and you have all your school material. The same thing as variable. Once you have declared variable as score is equals to 85. So whenever you need your score, just call the variable called score, and then you have it. So back to the condition I was explaining earlier. A typical example here is for some of you, like if you want to write a code, for example, in your school portal now, you wonder how does your school portal know that you score A or you have B based on your score and everything. This is a typical example of the code that they use to determine whether your score is A and everything in your portal. That's how it is programmed. So if your score is between, let's say between 90 and above, 90 to 100. Your score is between 90 to 100. Then you got 8. But if it is 80, you have B. But if it is another thing, like that. So that's conditional for you. If you want to know whether you have A or you have B or you have C, so just input your list. You can write the program for that, and you can use a conditional statement for that. So a conditional statement is just like you are trying to set a condition at which a program runs, or you have an input. You are setting a condition for something. So another one is called, you have another concept called loop. We have another concept called loop. And in programming, loop is just for repetitive work. Sorry, hold on, give me a minute. Okay, so sorry for that. So, as I was saying, loops are for repetition work. For example, let's say you are trying to run a task over and over again, a repetitive task, for instance. You are trying to run it over and over again. You can just use loop for it. And we have different type of loop conditions in loop. Loop 2 is like a conditional statement too, but we use it for repetitive tasks. So we have different types of loops function in C. We have for loop, we have while loop, we have do while loop, and we have we have for loop, we have while loop, and we have do while loop. So for loop is just used to run exactly something in a number of times. Let's say, for instance, you want to, okay, what can I use as an example now? Okay, let's say, for example, you want to draw an image for a number of 3 times. You want to draw an image for 3 times. You want to write a code to draw an image for 3 times, and then after that 3 times, it should stop. But your condition have to check, your code have to check for a certain condition. Like it has to make a certain condition to be able to draw that image. Okay, let me rephrase that, I think, so that it can make more sense to you. Let's take, for instance, now you write the code to ask a user that do you want an image? Then if the user says yes, then you ask the program to draw an image for the user 3 times. After 3 times, it should stop. So that is for loop for you. You use it to run a code for a couple of times. But if you look at while loops keep running your code continuously as long as it met a certain condition. Let me come again. For loops, for example, if you look at this for loop code that is written here, these guys, so can you just give me like 2 minutes? I'm happy to come. Sorry, guys.
Okay, Ishisho, are you here? Could you help engage while Ola is away?
Hello?
Okay, yeah, good evening, guys. We have all been following. If you have all been following, can I see like thumbs up almost? Okay, I see. Oh, okay, I see Favor, I see Precious. Okay, that means I see. Okay, yeah. Do you have any question for now? Something that we don't get? Like for now, let's just write it down or note it. When it comes back, we will get. Okay, Emmanuel wants to say something, so I can go ahead.
Okay, so guys, I want our honest feedback on how this session is going. So are you really following or you're just enduring? Which one is it? Let's use the chat this time around on the group. So let's use that as a mid-session check-in.
Oh, like I'm
Okay, yeah, let's do that. What's up?
Hello,
Okay, I see
can
two
you hear
people
me?
typing.
Hello, sorry, can you guys hear me?
Okay, are you back?
Yes.
All right. You can go ahead.
Thank you so much. I'm so sorry for that. I was having a call and it was distracting my. So, as I was saying earlier, if you look at this for code, like this for loops code now, this is how you actually define it. Like I said earlier, your whatever logic you are trying to define or whatever function you are trying to define, this you first define it. Unlike a function now that we define the data type at first. If you look at our main function that we define here, it has a data type called int. That's just like a standard procedure for it. But in our for loop, you just write whatever loop function you are trying to define. For, if it is while loop, while. So you get. Then whatever function you are trying to define, first of all, you write the name of the function, which is for. Then in brackets is where you put your condition. You put condition in your bracket, followed by curly braces, opening and closing. Then inside the curly braces is where your code, the body of your code is going to stay. So if you look at inside this bracket now, we have int I is equal to 0. Then we use a semicolon. After that, I is less than 3. Semicolon, then I plus plus. So here, what we are telling our code is that I is just like a placeholder for a condition we want our code to meet before it runs. So if you look at I now, we set I, this is our initial condition, I is equals to 0. And we say that as long in the second condition, which is the increment, we call that one increment. So this is, and I'm talking about after the first one, we have int I is an integer now. So if I collect receive anything that is Boolean or that is any other data type that is other than integer, then the code is going to throw an error. So sometimes so that our code doesn't throw an error, there is something we call error handling. We will learn all of those things in programming language in the course in depth. So I'm just trying to let you understand the basics. So after this, the first initial condition where we set I to 0, we have the second district called increment, which is I is less than 3. So we are now saying that, okay, as long as our I is equal to 0, which is the initial one, then as long as I is less than 3, then the last this thing here, the last function here, I plus plus, then it means that increase I by 1. So we can now say that if you look at the body of the code, it says printf meow, like just like this thing, the sound of a cat, meow, for 3 times. So if you look at the condition is that I is less than 3. So I can be zero. If I is going to sound meow. Then if I is equals to 2, it's going to sound meow. But if I is equals to 3, then the code is not going to return anything. It's not going to make any sound. For some of you that might be interested in embedded system and all, basically we use C for that, for programming all this hardware, Arduino, Raspberry Pi, and all of that. Some of you might have heard about it. And so for some of you that are in 400 level, you'll be doing your final year project, this is also going to be useful for you. So let's say, for instance, you are writing a program that does something, but after your program like actually like perform a specific action, they want a buzzer or a speaker to make sound to mark a completion. So you can say that int is equals to 0. Your 0 can be okay, whatever action you want your project is about. Then after you like you have performed the function, as long as that function is meant, which is the initial condition we set here, so you get, then you can say that okay, print and make sound called meow, then your buzzer or your speaker that you attach to your display can make sound meow for like 3 times. This is what this thing is actually like. What for loop is all about. For a particular amount of time, you repeat a particular activities for a particular amount of time. But while loop, on the other hand, that one never stops. As long as the condition is what is true, it continually checks whether the condition is true. It continually checks for the condition. Unlike for loop, it only checks for the condition once. And after the condition is met once, then perform the action. That's the end of it. But while loop continuously check for the condition, and as long as the condition is met, it continues to run. So why does this matter? For example, now in AI, for someone like me that I train a lot of machine learning models, AI, and all of that. So this is actually like helpful because by the time you are trying to run AI, like we have something we call like training loop. Training loop actually basically means you are not training AI like just once. Sometimes by the time you go in depth into AI, there's something we call epoch. If you set your epoch number to, let's say, a number 10, you are telling your AI, you are telling your AI to train itself like 10 times while you are not there. So you don't necessarily need to be there to be training your AI the first time. After the first time, then you manually training the second time, No. There are times we want to test it for you want to train your AI for a particular set of time. So if you set your epoch time to like, let's say 10 times, then the AI will go on training on a particular set of data for the first time until it makes that certain amount of number. That's one. Two, for while loop now, for some of you, you have to be cautious of using this while loop. Most times you need to break it. Most times you need to give an end to it. Because if you don't give an end to it, that's why I don't know if you have heard about this condition called infinite loop in programming, whereby your code or your program enters an infinite loop. Whereby your code enter an infinite loop and it's continually running, like it's run continuously. It run continuously. Okay, I think Emmanuel has the question. Oh, you can't hear me. Okay, you can hear me. Okay. Thank you. So as I was saying, where sometimes your code tends to run infinitely. Guys, please give me 1 minute. My laptop is going to run down. Let me just plug it. Okay, sorry for that. I'm back. So where your code, like I was explaining the while the infinite loop rather, your code continues to run like infinitely, just continue running and you can't stop it. And at that time, if your code is running if like enters an infinity, trust me, your laptop will start hurting. Why? Because it is going to eat up the memory and all the resources on your laptop. It's going to eat up the memory and all the resources on your laptop. So you have to be very careful while you are using the while loop and everything so that it doesn't eat all your memory, and sometimes it do crash your laptop and all of that. So let's move on to the next slide. And now this is basically explaining the limit of hardware. Like the hardware we have has a limit to what you can do, especially in terms of memory and memory management. There are a lot of limits to that, and I believe you will learn more of that in the code. So, okay, now what like the word make Elo actually does. So for some of you that have tried to watch the video and you don't understand, the man using the word make Elo.c and all of that. So, like I said earlier, if we go back to this, I said this, if you look at the middle, the compiler now, we use a framework or a compiler called Clang or make. So basically, if you write a code, for it to run, you need to a C code, for instance. Before you run it, you need to compile it, assemble it, and then link everything together. Although you don't need to manually do all of those things, just know the command to run it, then your code will run. Like the Clang or make command, we actually like do everything for you. It's going to pre-process your code, compile it, assemble it. For some of you, by the time you write your code, before it's even compiled, at the pre-processing level, you'll be getting error. So that's a typical example of it. Some of you, your code will not compile. That's why you hear people say, my code does not compile, the code is not there. It's showing error and all of that. So if there is error in it, instead of it crashing the compiler, it will just throw an error as your own end. Then you get, so the make command is just to compile your code. It's just for compilation. Then visualization memory. Like I was saying earlier, you will have heard me mentioning a lot of times in this for the past couple of minutes that memory is very, very essential in programming, especially in C, and we use C for memory management a lot. Okay, let me just use this concept to explain it. If you look at my screen here, it says you can picture a RAM as a huge grid of mailboxes. Every byte has an address. That's why most of our laptops, you see some of them have 8 gig RAM, 16 gig RAM, and a laptop of 16 gig RAM has more capability than a laptop of like 8 gig RAM or 4 gig RAM and all of that. So this is a typical example that I show you that why all of those things matters and why memory management matters in programming, because they use code, and like I said earlier, most of our operating system are written in C, and when they were writing all these things, they put memory management into consideration as much as they could. So let's take for instance now, like you might have been wondering, what is the memory? What does memory mean in actual sense? Is it the devices I hold? Is it the memory? Like, what is the memory? So let me just break it down for you guys. You can picture memory as a grid of mailboxes. And what does that mean? Let's say you have a mailbox. Oh, we don't really use, we are not in 90s again, where there's no, in post office, we have a lot of mailboxes where you go, you put your mail inside, you go and collect email and all of that. So there are a lot of boxes that are assigned to all of those things. If you can picture that now, even though some of what doesn't mean that thing, but just picture it. Each boxes of a mail, like just picture memory as a grid of all these boxes. That's how it is. That's what memory is. Each box is here is a representation of memory. So if you divide the memory now, it's like we are dividing a memory. All of these things from 0 to 31 is like a memory. Then let's say we want to store some words or want to store an information, a data into this memory. We store it inside 10, 11, 12, and 14. Mind you, if you are trying to retrieve something inside the memory, most times the memory does not actually know the content of what it is holding. It just holds the address of that content. It's like you drop your mail inside the mailbox. Now, I'm not talking about the email, the electronic mail you're using now. I'm talking about the olden mail, the olden days mailing system. You drop your letter inside the mailbox. You know, the mailbox as a memory that holds your letter now doesn't know the content. Even all those people, like those people that work at the post office and all of that, they don't know the content. They can only like give you the address. Okay, you are coming from so places. This is the address to your letter. So every memory does not know the content. Your laptop, even if your laptop is, let's say, 500 gig or 1 terabyte, whatever you store on it, the memory itself does not know the content. It only stores the addresses of those contents. And it is the address that you'll be accessing most times. So, like I said, the int, like for example, we make mention of int score the other time, and the computer finds 4 empty mailboxes sitting next to each other. It serves them and puts your number inside. So the way memory store data is it tries to know the first box of your the first box. Like I said, let's say you have you are storing a data of 8 MB, 8 MB, and let's say each box here represents 22 MB. So that means you are trying to store an information of 8 MB. Then that means you need definitely 4 boxes to store your data or whatever information you are trying to solve. So most times your memory does not know all the 4 boxes, but one rules that the memory abides by is it knows the first box, it stores it, and then it knows that the next sticky box after the first box is going to be the content. So it knows the first box and the size of your data you are trying to solve. So I hope that one clarifies that. If you don't have a question, please. If you have any question, let me know. But why is this like matters in AI and all of that? So CUDA out of memory. So in this picture with full of boxes, a tensor is a reserved block of exactly this kind. You are just reserving millions of neighbors at a time. For some of you that is going to go in depth into machine learning and in depth into AI engineering, like myself, you will need this a lot. Like, and you will find it very interesting because you use CUDA a lot and you use memory a lot, and it's one of the things like you are going to suffer with. Don't let me use the word suffer. Like you are going to find it interesting because by the time most people, let's take for instance now, we have only seen like all these Americans and Chinese developing AI like language model like ChatGPT, OpenAI. We have DeepSeek and all of that. Sometimes we wonder why couldn't we do it in Nigeria and all of that. The question is sometimes it's technical expertise, and another thing is infrastructure in terms of all this memory and all of that, because the memory needed for training AI is not just like the kind of random one we have in our normal day-to-day laptop, CPU, and all of that. It requires GPU, and all of those like are in form of memory. So this is why this matters a lot. So that is that. Oh, see, our time is fast spent, and I'm just getting to argue. So I think this one will not be talk. So what is array? Array is just like a block representation of informations What do I mean by that? I said earlier that you can store an information inside a container called variable. So let's say you store, okay, I made mention of my school bag the other time. My school bag. Let's say you name a variable called my school bag, and inside that variable you store pencil, comma, you store notebook, comma, you store your pen, comma, you store those three things. For example, you store those three things inside your listing. You see this variable called my school bag is not an ordinary variable again. It's called an array. This is a typical example of array. It contains like more than data. And in some cases, we have some arrays that can contain like more than one data type. For instance, now you can store for example, you can store, let's say, my information. You name a variable called my info, and you now name it. You put my age to be 20. You put 20 inside. Then you put what's it called? You put your name. Let's say your name is Emmanuel. You put Emmanuel there. Then next thing you put what's it called? Your height. Let's say your height is 175 centimeter. You put 175 in it. So if you look at this type of information now, this type of variable, it has more than one data type. Called it has one character inside, and let's say your age, your height is also full inside. So okay, thank you. So as I was saying, like there are some arrays that allows you to store more than one data type. Like you can store an integer, you can store a character, and you can as well store a floating point number inside of it. For example, now this one now, in C, this is how you divide an array. The data type you want to put inside, then the name, let's say your score now, scores of 3 people. So inside it, this type of bracket is what we use to represent an array. I say brackets now, like we have different type of brackets. I forgot what we call this one. Okay, I think I will remember later. So if you look at this type of brackets, the 3 is written inside. Where we have this 3 is written inside. Yeah. So that's how we represent an array. And you put for example, if you leave it empty now, let's say you say int score and you leave it empty, that means it can contain infinite number of data, of information. But since we put 3, that means it is expecting 3 information. So, and you can access information inside an array through their memory allocation. I was mentioning something the other time that a memory does not know the content of what it contains, but rather it stores the address to those memory. Let me use array as an example. If you look at this array, we store 3 information inside of it. And let's say the first one is 72, the second one is 73, and the third one is 33. So this first one, it has an index, and we will access them by their index number. So it has an index number of 0. Remember, numbering starts from 0 in programming, it starts from 0. So it has an index number called 0. Then the second one has an index number 1. Then the third one has an index number called 2. That's how you access the information of an array. So if you want to access this 72 now, you don't just say find score 72. You index your array variable name, which is score. Then index is into index 0. Then that one is 72. Index 1, That one is 73. Then index 2, that one is 33. And at the same time, let's say you want to add an array, a number into this array now. You can even say score into that bracket, then 3 is equals to 40. You can add another index number to it like that. So that's how you access it and all of that. So why is this also matters for you? This you see this array, by the time you move into data structure and algorithm, you are going to need it a lot. Array is like a beginning of data structure. But if you know it now, trust me, there's a data structure like queue, hash, stash, and all of that. They are going to be
Hello, sorry. My laptop just went off now. So I think like this is actually like the last slide of, I think second to the last slide. So if you have any questions now, then I think we can go into questions. We have even spent a lot of time. If you have questions, please keep them coming now.
Okay, does anyone have a question? So we can make it fast. Because it's almost to 7. Let's ask our question now. Because everyone cannot just be saying that they got everything. I feel like one or two persons have a question. Or are we saying we understand everything? Is that what we're trying to say, that we understand every process that you just mentioned, that no one has a question? Okay, let's do it this way. Okay, Precious has a question. Okay, who else again has a question? Aside Precious. Let's just count it. So I know how many minutes I'm going to use for each question. Okay, this is another question on the comment section. Okay, 2. Then who else again has a question? Okay, Karen, that is 3. Love it. So who's the last person? Let's take 4 questions for we call it a day. Every other question will be dropped on the group. Let's take another one. Who else again is asking a question? Okay, I guess we can start from that. So you can go ahead. The first person that raised up his hand, can go ahead to ask your question, please.
Okay, sorry, let me quickly start from the group chat. Someone
Okay,
asks,
okay.
so the compiler is like an interpreter? Yes. So we can view a compiler is like interpreter, but for low level language. In high level language, we call them interpreter, but in low level language, we call them compiler. But they basically do the same thing, just interpreting from human language that we understand to machine language, from source code to machine language. So another person says, can we write programs with our phone? Definitely, you can write programs with your phone. You just need to download. In your laptop you use VS Code, but there are some mobile device IDE that you can use. There are some application you can use to run your code. You can use to practice and all of that. So I think if you don't know anyone yet, if you use let me know if you use an iPhone or an Android. I can recommend some that works effectively. So let's move to those that want to ask the question.
Precious, you can go ahead.
Okay, good evening, sir.
Yeah, good evening.
So my question is coming from those quotation marks. You are using
Okay,
those quotation marks when you are writing some of those codes. So like I
okay.
wanted to ask, are those the only quotation marks we have? Like
The quotation mark, right?
yeah,
Okay, what's your question? Sorry, I didn't.
the few ones you use the semicolons and the rest. I was asking that are those the only ones that we have? And if there are more, I'm just trying to say maybe you can like write them down first, then maybe like their function and stuff to like for us to
Okay,
understand.
okay. Okay, I understand now. Then I will definitely do that. I will list them out what they do, and how you use them. I
Yeah,
will.
thank you.
Okay, you said you use an Android phone. Then I will send to the group like the one you can use that will work well with C programming language.
Okay,
So another
love
person.
it. Love it, you can go ahead.
Okay, sir. Good evening.
Yeah, good evening.
Was wondering that if it's possible that the slide can be sent to the group because my network was very bad, so I couldn't follow much on it.
The slide I used to this evening, right?
Like the slide they used to explain C language, if we can send it
Okay,
to the group.
okay, no problem. I will send them to them.
Okay,
Also, one
so
thing I'll just say is
cut.
that we share the recordings. I don't think we've shared the recordings for last week's sessions, but we'll do that and as well this one. This session is currently recorded, so
Okay, that is noted. So then Catalan, why C Catalan, right? I think we want to say something. I think we can take one more question, then we'll round up.
So what do you say?
I think we can take one more question, right? Then before we call it,
Okay,
let's take one more question.
all right.
Timmy, can go ahead.
All right, yes, I believe.
Yeah, good evening.
So my question is, can you quickly do a explanation on conditional statements? I was not really paying attention when you were. I was distracted for a while when you were doing the conditional statement. Can you just like do a quick, a brief explanation on it? Thank you, sir.
Okay. So sorry I won't be able to like share my slide again. My laptop just went off. I'm not at home currently. But I will try as much as possible. But if you still don't get it, probably you can message me whether tonight or tomorrow morning if you still have the time. I can share the screen and explain better to you. But what conditional statement actually what they do is like okay, let me use the example I used earlier. I was using the example of calculator. If you are trying to develop a calculator and you have different functionality for your calculator, an additional functionality, multiplication, division, and subtraction. So, at what point do you want to use multiplication? At what point do you want to use division? At what point do you want to use subtraction or addition? So at first, a typical calculator, you take input from the user and you have the keypad for mathematical operation they want to perform. Let's say the user type plus or the type minus. So in your code, you write that if user's mathematical operation is equals to times, then multiply whatever numbers the user input. At first, inside calculator, you put 2, then there must be whatever mathematical operation, whether times 2. So inside that 2 times 2, whatever the input of the user is, you look at the input. If the input is multiplication, then you say that if user input equals more times, which is multiplication, then perform a multiplication function. Else, else, if it is not multiplication, then check for the other mathematical operation. Else, for example, inside C now, you can use if else, you can use if, you can use else, and you can use if. I think inside Python you can use if, you can use if else, you can use else, you can use elif. We have different type, but you can just use if this action is true, then perform this. Else, do another. Else, perform another action. It's just like saying that if this action is true, perform this action. Like if this condition is true, perform this action. Else, perform this another action. I don't know if you understand. Hello, Karen.
Yeah,
Abi?
I, I
Okay.
understand. So I can say that if it is false, that else also means false. You should perform another function.
Exactly. It's just saying that okay, let's say in school now, if you register your cough form, if the condition is if you register course form, print your course form. Else, print blank form. Sure you get.
Yes, sir. Thank you, sir.
Okay. Okay. Thank you. So any other question?
Okay, I think with that, I think we are done with questions. Every other question can be dropped to the group.
To the
Then
group.
we'll see
Okay.
how we go ahead with it. Yeah, so
That's
Sir
fine.
Emmanuel, I don't know if you have one or two things to add before we call it a day.
Okay. All right, guys. Thank you so much, Mr. Olamide, for this evening session. So I want to believe that now, if you now approach C, there's some foundational knowledge that at least you have context now with the array. So let me help us understand the way the program is now structured. So myself, Olamide and Israel had a conversation last night, and we're really just looking at the length of the program, and we came to a conclusion that there's two things that can happen. It's either somebody's head fries or it explodes if we are to do this program in 4 weeks. It's two options, right? And we don't want any of those two options to happen. So we decided on something. We decided that we're still working around it, but we're deciding that we'll extend this phase 1 for another extra week. And it would not be, we would not go through the entire 10 weeks of the program. Guys, let's listen very carefully so that we can really put our minds together to learn and not be in haste to just watch videos and forget about it. Because if you for clarity again, the main goal while we are doing this is that at the end of the program, each and every one of you, by the time we are done with this program and you are getting to phase 3, where we are now actually getting into real companies to do AI transformation for them, to build things for them. And then for also on the side, let me also mention that we have already on the team started working out and started getting a couple of businesses that will be attaching people to, right? So by the time we get to phase 3, we want to be sure that you are grounded enough. It's not just someone that has watched videos but has no depth. It's just flying in the air and it's not grounded, right? So we have decided we'll do this in this way. Phase 1, instead of 4 weeks, would now be 5 weeks. Phase 2 would also be 5 weeks, right? And what we are going to do is going to be that for the CS50 program, because the first half of the program is actually the heaviest part, right? Olamide was saying on the call yesterday that you see the parts that has to do from Python downwards to even CSS and AI. Those are things that you can actually consume in maybe a week or a half. Because those ones, once you have the foundation of C, you have the foundation of algorithms, of memory, of all data structures and all of those things. This is where the real work is. So we want you guys to really focus on it. So what we are going to be doing now is this week, we are going to be focused on arrays, right? C plus array. C is a carryover from last week, but we are going to still, we would want you to, for those of us that have not taken it, take it again. By the end of this evening, by the end of today, after this session, I'll share the recording to this particular session. Olamide will also share the things he has requested, he has said he will share, the slides and all. So please take it again, really understand it, right? Because this is the hardest part and the crucial, most important part, right? For this week, initially we're thinking you would do 3 weeks, so do week 2, 3, 4, but we decided you just do week 1 and 2 again this week, right? The next week we would now do 2 again, we will now do 3 and 4, right? That's the third week of the program, 3 and 4. So I want you guys to just take a calm mindset and just be very relaxed. Our mentors are all in the group, so at any point you're taking this, just move at your pace. Like, just maybe not move at your pace, but move very fast, but still move fast enough to be sure you are understanding what we are sharing. So that's what I wanted to share this evening. And if you have any questions, so guys, I want you to know, like we said, we've dropped off 4 people from the program. And because we didn't mention it initially about engagement, that's why we still have people with 0% that are still on. But by the end of this week, we'll access again the engagement to really see. Because I'm noticing that some of you guys will just be chill till maybe like Friday. Then Friday, you just enter Turbo Boost and then just start firing and be watching all the videos like that without any form of engagement, without any form of, you won't learn that way, right? So you really have to go through it step by step. So with that, I don't know if there are any questions, any clarity you need. So like I've said so far, phase 1 would now be ending after 5 weeks. You would use 3.5 weeks for the week 1 to 5 of the CS50 program, and then you'll use the last 1.5 week for a project. Then for phase 2, you would use about 2 weeks for the week 6 to 10, and then use the remaining 3 weeks for projects. Okay. All right. So one thing I also want to add in is that, this is something that you can decide if you've really made up your mind and you're like, okay, this is really what I want to lock in on for this period. We are giving you everything you need to do that. But if you are still not sure and you are still winging it, it will also be very evident and very obvious. So that said, I think that's all I have to say tonight. Thank you so much, everyone. I have to say that I'm impressed. To be honest, I was speaking with the team at the beginning. I was like, if we have just 1 or 2 people at the end of the day that will join the team at phase 3, we'll be very happy. But by the time I was checking who are the people who are going to evict at the end of this, at the end of last week, I was just like, wow, it seems as if most people are getting in. So that's very, very commendable, guys. Very, very commendable. And from the conversations that I've had with each and every one of you, it's just obvious that you guys are really in on this. So please, let's keep up the momentum. Questions, answers, bring them as they are, and let's build together, guys. Thank you so much for joining this evening session. We'll just say a prayer and we'll be out of here. So let me take the prayers. Father, we thank you for this session. We thank you for how you've helped us to really learn and see what has seemed difficult before now. We're asking for more clarity. We're asking for more wisdom to understand these things. We're asking for focus. We're asking for consistency and commitment. In Jesus' name we pray. Amen. All right, guys, have a good evening. Let's continue the conversations. As you're dropping off, you can just go on the group and really just share your experience of today's session, how well it has helped you or otherwise. Thank you and good night.
They're done.